What we're going to talk about today is we're going to talk about recommended installation procedures. What does that mean? It means that we're going to go through a checklist. The importance of a proper job survey can't be overemphasized. Like all major elevator work, is the foundation on which to build. The following is a list of items to be aware of. However, it is not all-inclusive. Each job has its own particulars that need to be taken into account. Check items off the list below as you complete them. So, let's go take a look at the list, the checklist. Okay, we're going to start a job survey. The first thing we want to do is take a look at the job prints and their condition. Are they easily readable? Are they available? It's an important thing. Now bear in mind, we have 16,000 prints on file. So during the survey, one of the things you want to make sure of is that you get all the data plate information. The reason is if the prints aren't suitable or not job specific, you give us that information and we can probably match something in-house. We've got a lot of Otis, a lot of Dover, a lot of prints. Machine room location. If it's remote, plan accordingly for the possibility of difficult cable runs. Let me give you an example. Not recently, a couple of years ago I was down at Ventura. I went out there with one of the supervisors and a sales guy, and we sold some fire service out there. One of the things we noticed was, when we would go into the machine room, which was out on the 4th floor, that the machine room was separated from the shaft by a wall, but it was a cord wall. So they weren't going to get through easily to put any piping down to add the extra wiring that was required. So one of the notes they made was they had to get a crew in there to core out the wall so that they could run their piping. This is the kind of things you want to look for when you get on an installation. Well, how am I going to pipe it? Normally, the average retrofit requires approximately 7 wires down the hatchway to the hall station, the new hall station, if you're adding fire service. And more importantly, you need an average of 12 to 19 wires down the hatchway. But they got to get from the machine room, obviously, to the hatchway. So this is something you're going to have to take into consideration. So when you're surveying, you want to be aware of where the machine room is in relation to the hatch and what it's going to take to get that wiring from the machine room to the hatchway. In that case, as I mentioned, we suggested they get a company in there to core out the wall. The next thing we want to look at is check the location to install new fire service overlay panel in the machine room. And mark the location with chalk. If you're surveying it, figure out pretty much where you're going to be mounting our boxes. Now keep in mind that our fire service panel has a lift-off cover, so there's not a whole lot of issues with clearance. Used to be we had a swing-out cover, and that created a lot of problems with clearances according to the new codes. But now our cover is lift-off, so you can pretty much mount this anywhere. My suggestion is always mount it on the side of the existing control. In the case of Otis, for instance, Otis comes in a nice steel cabinet. Mount it on the side, chase nipple through, you got no piping, no wiring. I mean, no real time-loss piping. In some cases you can't do that, like I'm going to show you some slides later on where they did a GAL. Was it a GAL? Pretty sure it was a GAL. Where obviously a GAL is an open frame control system, and there was no place in this little tight motor room to mount it on the controller, so they had to mount it on the wall and pipe over. But you still want to mark that area, and I'll show you why marking the area becomes important later on. Next thing is you want to determine the length of the hatchway rise so proper length of travelers can be provided. Remember, we have to add anywhere from 12 to 19 wires to the average installation when you're adding fire service. So you're going to have to determine the length. Plus you want to determine the length of the conduit or multi-cable that'll be required. Again, you can't do that unless you've already determined where you're going to mount the box. Am I going to mount it on the side of the controller? Am I going to mount it across the motor room? That all has to be taken into account, because when you survey the job, that all has to be paid for at the bottom line. And if you don't get it right, that's all added to the bottom line after the fact. That means your company eats it, as opposed to the building being charged for all of that material. Note, take motor room and car top cable run measurements into account. Remember that when you get to the car, bringing the cable to the car, the 12 to 19 conductors the car might require, you still have to mount something in the car to add the switches and signaling and the buttons. Now sometimes they do it by replacing the car station. Sometimes they do it by just adding a panel on the side.
Yeah, pretty much all of us. We do all of them with just an accessory panel.
Do you?
Yeah.
There you go. So you want to take into account where my interconnection box is. Is it on the top, underneath, behind the tow guard? And then what it's going to take to pipe in and mount your box. So that has to be taken into account. I'm talking more about time than materials, but the material is important as well. Then you want to determine if there's at least 5 spare conductors and what type. Within hoistway conduit at the bottom of the hoistway, having enough spares would obviously eliminate the need to run conduit and wire for phase 1 switching in the fire. But you're going to find, as I used to, yeah, you seldom find spares. And if you find spares, they're seldom good. I'll tell you a little story. Give me a second here. We did an overlay for a guy. We were doing a couple of Dover cars, the old card racks. And what happened was, oh, gee, I got lots of spares. Oh, that's great. I don't have to run a travel. And he had about 12 spares. Turns out every one of them was grounded.
Yeah.
So when he used them and put the switch in, the controller went crazy, as you can well imagine. I troubleshot it with him for about a day and finally told him, this ain't working. You got to get a new traveler. Because then we found short after short after short in the travelers. I never heard from the guy again. He went back, added a traveler, rewired it, that was the end of it. Actually, if you were to do a card rack, you'll find that a card rack installation is a whole lot faster than any of the other ones you're going to do. Only because we simply we don't go behind and go to the back plane. We simply use everything available at the terminals on the front, which makes it really simple. The only thing you have to remember is you have to isolate the hall button common, the hall button acknowledgement comments have to be isolated out separately. That's the big deal. But you're dealing with 3 or 4 floors maybe, so in the scheme of things, it's still quick. Now, another question you want to ask is, does the existing hall fixture box lend itself to an inclusive surface mount, or does the hatchway wall need to be chipped out and a new box installed for phase 1 key switch and fire hack? Again, a lot of people are just using the extended panel.
Yeah.
That's surface mount, which means you can get away without chipping. But that's something you have to determine. Like in some cases, you may not be able to do that depending on how they've constructed their lobby and what you find in the lobby. Determine what type of door reopening device is in play. The reason we need to know this is because if you have an electronic edge, we have to deal with electronic edges differently, obviously, than we would deal with a regular safety edge and electric guide. That's the code. We just have to provide you guys an extra piece of equipment to deal with that detector edge. So it's very important that we know whether you have a detector or not. I can't tell you how often I get a call from a mechanic. Gee, you know, you got this nudging unit in here and we don't have a detector. Oh. Or, you know, we have a detector. How are we going to close the door? We didn't know. So now we got to ship them out. And all that is time lost on the job. All that is money out of the company's bottom line. So it's important to know those things, be cognizant of it. And then we need to know what type of door operator, and that all, of course, relates back to whether we're going to do a detector or not. It also lets us know whether the operator is going to be suitable for a refit. Sometimes they're not. The next thing we need to know is you want to check the fixture needs and order accordingly. New phase 2 care panel location, preferably next to the COP or when necessary on the care wall. Then we want to identify which fire service key is required, and that's determined by the AHJ. Okay, determine the setup and pre-installation team. 80% mechanic, 80% mechanic and helper. Once determined, provide the team member with pre-installation checklist to ensure ease of installation. Check the necessary time to train and pre-install team to follow these procedures. Technicians need to know where conductors originate from and terminate to. All fixture panels should have the same wiring sheet so that each team member knows exactly which cable wire they're looking up, including the traveling cables. That's all pretty standard stuff, but you'd be surprised how many people don't think of it. I was surprised. That's why we included it. And I do a lot of the support work, so I'm talking to these guys all the time, and these are the kinds of things I hear. Install fire service panel machine room in pre-selected location, preferably on a controller panel frame or nearby. One of the things that we have learned over the years is the most efficient teams that do this do it because they send in a pre-team. The pre-team does all the roughing. They mount the fixtures, they run the cable, they mount the fire service box. And then the tech goes in and he does the wiring. That's the most efficient way to do this. You get your grunt work done by the guys that
That's
can't
my
wire.
pre-setup guy, right here. So I go in there, show them all this, here we go.
Then you want to pipe to the equipment, example, fire service panel to controller, selector, or where otherwise needed. This is where you got to be a little more up on what you're going to do. What I suggest is when you get the job from us, go through the prints. Some cases you're going to need to run wire to the Otis floor selector, sometimes. Sometimes not. Sometimes the coils are all located in the main control. I've seen both over the years. You must know what I'm talking about. So you got to know whether do I need piping over. Now, one of the things to keep in mind is this. Let's say you have a 10-stop elevator. Okay, that'll afford you approximately 38 calls to reset. Each call is going to require a separate wire to reset. However, what we do is we give you a small panel mounted in a small box. So you got 38 calls to reset. But what if I take the box and I mount it on the selector? Now, I only need 5 wires to the selector to operate that box.
Right.
And then everything is just from the box down to the calls. Makes it really easy and really quick for installs.
This is what we're doing.
And this is something that we developed over the years because we used to get complaints. Geez, I had to run 3 multis over to the selector because I have a 20-story building. Oh my God. So we did something simple. We decided to take this little reset panel we used to kill the Otis calls and relocate it to the selector where it really needs to be anyway. And then you'd be surprised how quick the install goes if you do that. You don't have all that wiring to run across and keep track of. I don't know if this ever happened to you, but when I used to do this, I had mechanics a couple of times run more than one multi in a conduit and then forget which multi was which. Yeah.
Yeah.
And then we get everything wired up and nothing works.
Nothing works.
It's like, holy smokes, what happened? So if you could avoid running more than one in a multi, that's really where you want to be. Install conduit and hoistway for phase 1 fixture, including phase 1 key switch and fire hat, at the designated floor. Note, though not typical, the floor location of this fixture may require AHJ or fire marshal approval. Don't always take into, you need to take that into consideration. Don't always assume that it should be at the first landing and second landing. A lot of AHJs don't like that for a lot of reasons. Unless it's very obvious that that's where it has to be, that's what I would be doing. I would be checking with the AHJ to make sure that you're going to mount that in the correct location and it's going to comply with what they have in mind. If necessary, install multi-conductor cable within newly installed hoistway conduit and terminate wires at phase 1 fixture. Note, wiring to all fixtures shall be with the same master wiring sheet. Very important that you use the same sheet, including traveling cables on all jobs and done by lead technician. Okay, this is where the lead technician now comes into play. Determine whether or not the COP, door opening device, and wiring to the operator are going to be wired in at the controller or at the respective places on the car, whether within the car, the cab, or the car top. One of the things you got to keep in mind too is a lot of times we're forced to go to the car top to monitor the door open limit, especially on Otis elevators. So you want to keep that in mind. If you're doing an Otis car, Otis is specific. They don't bring a lot of stuff directly back. Sometimes we have to go to the car top and isolate things like the door open limit by virtue of the way the controller was constructed. So you might want to keep that in mind as well. On Otis cars, you're probably going to be putting 4 to 6 wires to the car top. Properly installed, home run, traveler, top of the hoistway, and to the elevated cab that terminates wires to cab fixtures that has phase 2 key switch and fire hat, as well as door open, door close buttons. Reminder, wiring to be done to all fixtures with the same master wiring sheet and done by the lead technician. Important, new wiring is not to be interfaced with elevator control or new fixtures until the time of final installation to control by lead mechanic. You don't want your rough team hooking up anything. get the wires in there, give me a couple of feet hanging out at this box, at that box, give me 3 feet or 5 feet at the controller, we're good to go. The multi-conductors, the traveling cable should be stripped and ready to wire, and fire service overlay panel and control, and all other points where needed. Again, this is kind of important. You want your rough team. Your rough team should be in and out of that job within a day and a half. That's average. But you want that rough team, when they leave the job, leave it in such a way that the lead mechanic can come in, not waste a lot of time stripping travelers, which used to take me forever. I don't know about you guys if they have new tools, but I used to sit there with the knife trying to strip the traveler. That would take an hour. That's what your rough team has to do. When you get there, that wire should be all loose, hanging out, and your run sheets should all be available. And again, don't make more than one run sheet. I'm going to show you when we go on that we actually give you a place where you're going to install the wire, cross cable, connect numbers and all. The installation wire should follow the master wiring sheet supplied by Electrodyne. We're going to go through the master wire sheets. I have a whole set of slides for that. Lead technician that is familiar with the existing control, and this I cannot emphasize more. Do not send a guy on a Westinghouse duplex who has never seen a Westinghouse controller. He will make you crazy. He makes me crazy. I know because I support them on the phone. And I'm forever faxing them or emailing them contact count sheets that match their controller. I have all the old Westinghouse books. I used to be, among other things, a Westinghouse adjuster many years ago. So I have all the books. And in the books, they have all the contact count sheets. So depending on the relay you're dealing with, depending on the vintage of the controller, will depend on how the contacts are counted. Well, counting contacts is obviously part of what we have to do. If you send a guy out there who can't count Westinghouse contacts, he's going to be dead, or he's going to start wiring things in the wrong place. Well, it's important that the wire mechanic knows the control system, and if he doesn't, get Electrodyne on the phone. We can send him aids, we can send him contact counts, we can send him a lot of stuff to help him before he begins the job. But I can't emphasize that any more than I have. Technicians should then perform any troubleshooting if needed, and final adjustment including trying the fire alarm and performing pre-testing. This is after the installation. But one of the things you want to keep in mind too is when you first get to a job, if it isn't your job and you guys are not servicing it and you're out on somebody else's job, run the car and make note of any flaws you see. Geez, the car didn't level. Oh, wow, the third floor call didn't set. Oh, wow, I got 3 light bulbs out here. Hey, my detector edge isn't working. Make a note of all the deficiencies that you run across. Once you do that, when the job is done, you and I won't be troubleshooting those extra things, because we'll fix them up front. We'll get that car running correctly before you begin. That's kind of important as well, and that should be kind of observed during the original survey of the job. Of course, once you get the system installed and you fire it up, one of the things to keep in mind is when you install our panels, fire service for the most part, in the main panel you will see nothing lit. It is dead. It doesn't light up until you fire it. The reason we do that is because a relay in that panel may be critical to operation. We don't want that thing operating for 3 years before there's a fire in the building, at which time the relay may or may not fail. I don't want to depend on that. Fire service is kind of important to us, and it's kind of a dangerous operation. We want our stuff to work when we need it to, so we keep every relay on our board dormant. The only place you'll see relays operating is in the little nudging board, and that's only because when you add the little nudge package that we're going to provide if you have a detector, it also adds nudging to the automatic operation. So because it does that, it has to operate all the time. But again, we're not dependent on that little board, ultimately, for fire service operation. Now I'm going to give you some recommendations. I may have to now reiterate what I've been saying. Through experience, installers have determined that the number of times there are enough spare conductors in existing traveling cables is less than 1%. This is why it is highly recommended that a small traveling cable be home run from the car to the fire service panel. Again, I'm reiterating some of these points. The pre-installed team should pipe from the fire service panel to the controller and all other necessary equipment, like an Otis selector or the group panel on a multi-car job. Sometimes we have to get into the group panel. Dover doesn't use a group panel, or didn't. A lot of the companies did. So if you got to go to the group panel, and you have a group panel, make sure that you can pipe over to it. We're going to be sending something over there. Usually no more than 3 or 4 wires. Usually we try to keep that number down to a minimum, so all you're running is half-inch conduit. We're not looking for a big multi going over the group panel if we can help it at all. Home run multi-conductors, the fire service panel from lobby key switch, or added car fixtures. These are the things that we want to see. We want to see a home run so that you have the wires on both ends. And when the guy goes in to finish up and wire up the system, he knows where he is. He's got both ends of the wire, he goes for it. And don't allow the pre-install team to interrupt the existing car operation. They should only install and mount components as well as pull wires to where they are required. You do not want the liability associated with working on a building fire alarm system.
Yeah.
Okay, one of the things you have to keep in mind these days is this. In addition to the 2 normal zones that we've always had, we've had lobby zone, all other zones. We have a 3rd zone. 3rd zone is motor room hatchway. Motor room hatchway zone. Now, I've seen, and it's down here, and I've seen a lot of them down here, where you have a duplex system but on opposite sides of the hallway. Well, if I use one hatchway signal, it won't work. I need a hatchway signal individual per car, and our system is designed to do that. In fact, I got a call yesterday from a guy that was giving me a rash of shit about it. How come I need one for each car? I have 4 cars in a group. How come I need a signal for each car? I said, where are your hatchways? He says, well, 2 are on one side of the lobby, 2 are on the other side. I said, well, you got different hatchways? Well, if I use one signal and set it off, I'm going to flash the hi-hat in all 4 cars, right? Yeah. Why would I do that if I only have smoke intrusion in one hatchway? Then he got it. But we never know. At our end, you know, if we could get a sales guy to give us accurate information, no offense, we wouldn't have to do this. But when I tell you that that is scarce at best, it is. So what we did was, we incepted, when we had to add a 3rd zone, we decided, we've got to make this individual per car. So if you have a duplex, you need 2 signals, hatchway motor room for each car. 4 cars, you need 4 signals for our units. And that's only because we never know the location, we never know the layout of the building. So it's something to keep in mind, because you're going to hand a spec off to the...
Problem is, yeah, they won't give me 4 signals. So
if that's
we end
the
up
case,
having to interface it ourselves, use a relay.
if that's the case, we have little boards that we can add. We have a small little 2-relay board that can be mounted right at the bottom of the fire service cabinet. You can bring that single signal in and then do what you got to do with it. I've sent those out lots of times in those situations. Teams need to be outfitted with the proper tools, along with a description of the job site, visit, survey of where the panel and fixtures are to be located. Lead technician needs to create pull sheets and inform the pre-install team of how many wires to pull between panels. Note, we recommend 20 conductors, 18-gauge traveler, and a 39 conductor, 18-gauge multi-cable. Now, 39 doesn't always do the job. Sometimes you might want to run a 39 and a 19. We average around 45 wires. 39 usually is on the edge. We always recommend running a couple of 39s.
It's full 61.
Yeah, or a 61. It always pays to have extra. What's required? Proper length of 20 conductor 18-gauge traveler should be ordered with strain cables so it'll hang properly. Yeah, I've been in hatches where they didn't use a strain cable. You know, they just tied it around. Doesn't work. Remember the strain cable. It is not a large cable, so it is easily handled by 2 people. A complete job will have a few spare conductors. Proper length of 39 conductor cable. Okay, you want to make sure that's right. EMT and flex should have that. All fixtures, fire hat, key switch, suggest possible use of service mount type. Okay, we've already covered that. Cab fixtures to include box mounted on the wall. Box should be located, should be locked, should have a lock cover to conceal door open, door closed, full cancel buttons, as well as phase 2 key switch. Electrical wire connectors, electrical tape, butt splices, we know that. Proper signage, check with the HJ for wording differences, and there are some around the country. Tools needed. You need a quarter saw, sawzall, EMT cutter, conduit bender, knockout set, drill bits, rotary hammer, grinder, die cast, hand tools, tape, and connectors. Required signage. This is kind of important. This is the signage that are required by most HJs and by the code. It's pretty clear. Make sure your signage matches it. I hate to see you guys fail an inspection because the signage was wrong. That's already covered in the handout. Now, these are two interesting things. This is what the layout out of A17 looks like. For your open, close button, all of the other stuff. Now, the fixture manufacturers all know this. This should not be on you guys. When you order a panel, what is on you guys is this, and this is on this side, if you'll notice. Here it says Electrodyne standard button configuration. Now notice, when we created this system, we did a couple of things that we thought were done. We did them to simplify what it is we're doing. Everything, if you'll notice, is simple, single pole, normally open. Single pole, triple throw switch. Not magical, no overlapping contacts, very simple. The remote switch is a simple on-off switch. Now, the next thing is a door close button. It's a simple, normally open door close button. And of course, the last thing is the in-car fire service key switch. Again, it's a single pole, triple throw switch. Again, nothing magical, nothing special. Buy it anywhere, anytime. And that's kind of the reason we did all of that. Okay, this is the typical survey sheet that we use. This is what hopefully, the sales guy with a technician along for information might be able to work with. And it asks all the simple basic questions. We're looking for the building name, controller type. We want to know how many landings. We want to know if it's, is it Otis touch tube or mechanical, if it's an Otis car, very important. It means either we added an extra piece of equipment or we don't. Also depends, by knowing that, when we get prints, sometimes the prints that we see could have both on them. We don't know. So a lot of times we rely on what we get back on these survey sheets. Let me give you an example. Almost every relay logic Otis ever did between 1962 and 1973, all the UCLs and AULs had 2 to 3 different operators on the print.
Oh, yeah.
Because they never knew either what operator would end up on the job. So knowing the door operator is extremely important, not only for Otis, but absolutely for Otis. Because when we get those prints from you folks, a lot of times we don't know what operator you have. And each operator has a different controlling circuitry, has different controlling logic. But we don't know which one we're going to draw our system into unless we know the operator. So knowing the operator is extremely important. It's a key to what we do. Otherwise, somebody's going to have to go out there and identify the operator later. And that's just time lost on everybody's end. We'd also like to know what the normal and alternate return landing are, if that can be determined at the time of survey. Because we set up, and sometimes Otis is, keep going back to Otis, but this kind of goes across for all of them. Sometimes we have to take special care to make sure we stop on the alternate landing if it's not the bottom terminal. We set up a circuit we call a hard stop. We don't know where to set that up. Are we going to hard stop on 2, 3, 4? So knowing the alternate and designated landing. Sometimes the alternate landing is the basement, and the designated landing is the second landing. So we got to know that. And we'll set our system up accordingly. I can't tell you how many times I get a call from a guy in the field who says, gee, my alternate and designated aren't right. Now I got to walk him through it. It only takes me a few minutes. It only take him a few minutes to fix it by virtue of the way we designed the systems. Switching them around is easy, but it's time loss. Time loss for him, time loss for us. So that's important that we know that. It's the type of operator, we covered that. Is emergency power present? If emergency power is present, we have to know that, because there are times, certain elevator systems, where we have to add an extra panel to deal with the emergency power situation. It doesn't happen often, but it does happen, and we have encountered this on numerous occasions where we've had to send a panel out, delaying the job, getting the mechanic off, bringing them back, to install the last panel because we didn't know going in, even though the print may show emergency power, that it actually existed. So that's a key question. And for Otis, are you going to use the Otis key switch? Okay, and this is what the panel will look like. Here's your main panel. Now mounted in this panel below, I see a nudging unit and what we call an ACX unit. ACX is just the way we control an AC door operator. We're able to slow down an AC door operator within code requirements without putting a VV-VF drive on the motor, and that's the way most people do it. We actually have a small board that can control the old Otis AC operators. And by doing that, we save the building and the company a lot of money. Let me explain that. When you add a detector to a job, code requires us to be able to close the door at low speed, low torque. Well, if you have a three-phase, quarter-horse AC operator, that's an impossibility, right?
Very hard.
But we created a little unit that actually can do that. It has four speed settings on a rotary switch, and we simply clip the phase. And by clipping the phase, we're able to actually slow that door down to code requirement. So then you go into the customer, and instead of telling them, oh yeah, well, we got to rip out your door operator because you got a detector and we got to slow it down, you don't have to do any of that. You don't have to touch the door operator. What I recommend though is if you guys do run into a situation where you have a 7300 operator on the job, check the 2 micros underneath. We're going to rely on those micros for signaling. If we don't get the signaling, the system isn't going to work. And I can't tell you how many times I've had to tell a guy, go down and change the switch because those switches get oil soaked, they quit. The Otis control will never notice it. You will never know. You'll never get a call, oh, the door isn't working. No one will know until you try to overlay it. And then you're going to find out the open limit is bad, the close limit doesn't work, and they're things that we rely on for fire service. We have to know when the door's fully open. So a lot of times the guys end up having to change those switches. So during the survey, make close note of what kind of operator you have, if it's an Otis car, and make sure that those switches are operable, that they're not completely gunked over with oil, which is what I used to see all the time when I was in the field. Now, one of the things that I want to point out is, on this panel, we have a sticker. And the sticker is very specific about how to drop the panel. If you'll notice, well, you can't really see it well in this picture, but across the bottom of the panel is a hinge. And this panel is capable of folding down like a shelf. And the reason we do that is if, God forbid, you should blow a trace at some point in time, the panel is now accessible and repairable. But, and this is a big but, it's only accessible and repairable if you brought the wire in at the bottom. If I bring the wire in across the top and I wire everything, there's no way that panel is going to drop down, right? So that's what we're trying to tell you with this little sticker that we put on the door. All wiring must enter the box below the hinge line, down here somewhere, so that when you wire it, this thing can still swing out if you need to swing it out. Now, we generally don't have you guys touch this thing. This is for future. This is in case a repair has to be accomplished after the installation. Generally, if we miss the boat and we screw something up, we'll send you a panel. We don't ask you to do that. We'll just replace the panel. But if it's wired correctly, replacing the panel is not a big deal either. So that's kind of what the sticker is all about, and we actually tell you how to drop it. To drop board for service, remove hold down screws only. And then we identify where the hold down screws are. And then we tell you, do not remove these screws. The hold down screws are the ones that aren't colored in. Now we're going to look at a typical installation. Now you notice he's got some tight clearances here. But because it's a lift-off cover, he was able to mount this unit on the wall. And then he piped it out to where it all had to go. Looks like this piping goes up. Not sure where that goes. Hard to see from this
Almost
picture.
looks like poise.
Well, we got a better picture here. Anyway, that's what the panel would look like mounted. You notice he brought all his conduits in at the bottom of the panel. So he's following our suggestion. Here it's in and wired. Again, The way he's wired this panel, the whole thing, by taking out the basic mounting screws, and the panel will drop easily. He's left himself enough slack around it. Actually dressed it up pretty nicely. This was a pretty nice job they did. It's a little duplex system. Now, this kind of shows what's behind this particular control. I'm pretty sure, yeah, this is GAL, right? It's the old GAL Select. Remember those? I got my fingers in one of those one time.
Oh, yeah.
I can show you the scars. Got me good. Anyway, he didn't really dress his wire the way I would have. However, if you'll notice, he made all his connections nice and clean on the back. There are times when you're going to have to cut and splice. We're going to look at some prints and we're going to talk about cutting and splicing. Here's another shot of the same controller. Okay, one of the things that we supply in the cover of the cabinet is what we call a roadmap. Now, Dover used to do this. I stole this from the Dover people, because in the old days they had roadmaps. And you were looking for a relay, it was easier to find it on the roadmap and identify it than it was to look at all the little relays that were usually covered with carbon dust by the time we got to work on them. So we stole that idea from them. We thought it was a good idea. So that's what we do. So if you're looking for a particular relay, you want to check some circuit, go here first. It's going to save you scanning all of these on the boards. We try to make them as legible as possible, but believe me when I tell you, they're easier to read on this sheet of paper. Now we're going to get into the pony sheets. These are the 8.5 by 11 sheets we're going to supply you folks for the installation. Now the pony sheets start off with an information page. On the page we give you, of course, the company, controller type the system is designed for. Notice at the end of this we have a drawing number. In addition to, like a notice, in this case a 2050U. Drawing numbers on notice are extremely important. If we discover that the print isn't accurate or that there's something wrong that we can't read it, we have about 7,000 notice prints on file out of the 16,000 prints we have. So drawing numbers are good. Drawing numbers are always good. Dover, again, drawing number, for Dover, we like dates that are on the controller. That all helps us identify a particular print in case the print that you sent us isn't going to work for us. Now, the second page of the ponies is our relay nomenclature page. Kind of gives you an idea of what all the relay names are. And pretty much we try to name them to identify their function. Pretty much like all manufacturers do. The third page now. On the third page we give you contact count for the 3 style relays we use. We use a standard 4-pole relay. We give you, if you count the contacts from the front of the board or the back of the board. Again, with the 3-pole relay the same, front, back. The 4-pole latch, although it seems to be counted like this, is missing 2, 3, 6, and 7. So we show you that. We also give you front count and rear count. Now, because we're who we are and doing what we had to do, we created a group of what we call symbols. And those symbols are like a little shorthand for us. We use them on prints, we use them on our prints, we use them on the job prints. The first symbol identifications that we use are generally located on our print, and they indicate the function of the different relays. Let me give you an example. Indicate relay found on master board only. Well, if you've got a duplex system, you may have 2 boards. One board is going to have what we call a master section. Instead of duplicating that section for every job and every car, what we do is we simply send the signals into the master board, and from there, we control all the other boards as slaves. So the master section is only required on one unit in a group system or a duplex system. So we identify those relays by coloring in the lower left-hand corner. The next relay indicates relay connected in parallel, numbered in order. Our prints don't show every single relay on the board. Our prints, for instance, we have relays that number FS through FS9. That's 10 relays. We don't show 10 relays on our print. What we do is we use this symbol. So you know there's more than one of those FSs, and then along the top we give you the number, maybe 2 through 9, or 1 through 9. So these are all, and I'm not going to go through all of them, but this kind of gives you a basic idea of the symbols we use on our prints. Now, interface code. This is extremely important. Let me explain to you why. When we go to interface this system, as we go through these sheets, you're going to see, we're telling you, take this terminal of ours and connect it to a terminal or a contact in the controller. Well, these are the symbols we use to do that. Sometimes we're just going to interconnect terminals on our board. Again, we have a signal or rather a code or a symbol that we use to show that. If you see an X, it's a terminal on a fire service unit. Now this will become really clear once we get a little further on. So I'm not going to go too far into that. And the third thing, or the last thing we have in here is just variable components that we use depending on the controller voltage. And this is more for us, but it gives you an idea too of the values of certain components. We have what we call a JFS relay, or a Joule flash system relay. And the Joule flash system relay is controlled, and it's basically a little cap timer. And if we're using 110 volts, this tells you what those values should be for CP or CN, the RJ1 and RJ2 resistors, and of course the diode. So this tells you what the value. If you notice, the values slightly change depending on the voltage. Some of them are drastic at 24. The difference between 24 and 240 is drastic. In fact, we're using a 12-volt relay here. In 110, we use a 110-volt relay, and in 240, we use a 110-volt relay. This is in case something isn't working, you can verify what should have been mounted in the board. We started doing this a long time ago because we used to build a lot of these boards. And my assemblers used to screw up once in a while and end up putting the wrong component in. So this gives you a chance to verify that, if you have an issue with it. Now, this is a key sheet that's going to be kind of important when you're laying out the job. This shows the fire service unit. It also shows the reset panel and selector if it's supplied. Then it shows the fire service unit to the controller. In this case, we're looking for 44 wires because we counted them up. We're looking for 3 wires between the fire service and reset unit. This actually this could be 3, could be 5, and this is left blank because we're not sure at this point. I didn't do this, but this should be filled in too if we're going to run wires from the reset panel to the selector. That'll be filled in as well. Like I said, for 10 stop, this would have 38. Then from the reset panel, how many wires are going down to the hallway? Okay, we tell you 7, and we tell you what terminals they'll be connected. Those wires will be connected to at the fire service end. And how many wires going down the hatch to the car? Well, in this case, we had 5 to the junction box and 12 to the COP. Again, we're giving you all the terminals heading down there. We also added a couple of spares in, if you'll notice. So that this is a really good indicator that you're going to have 12 to the COP and 5 to the junction box. Now, when we say junction box, we're talking about the car top junction box. So we kind of lay all this out for you. Now, and this obviously is a duplex system. So we're telling you, okay, we're going to interconnect the master car, which is car A, to all the other cars, in this case 2 of them. And these are the terminals that are going to interconnect the 2 cars. 1, 2, 3, 4, 5, 6, 7 wires between fire service panels. They're your basic interconnects. And we give you the terminals that are going to be used. Now this isn't the only place you're going to see this. As we go through the ponies, you're going to see that again. Let's take a look at, okay, the first sheet of the wiring basically shows our stuff. It also shows where you're going to be connecting your sensor inputs, where you're going to be connecting your key switches. Again, this sheet is pretty much the same thing. And up here, if you'll notice, here's where your hatchway motor and sensor input is going to reside. And here's your car fire service key switch. But don't worry, you're not going to be wiring by those. They're more for troubleshooting if something should come up. Now here's a typical Otis print. This is the print before we got our hands on it. This is the pony sheets that are showing you, for instance, you're going to connect V8 to terminal RT1. Now you see that sideways sign and greater than sign? That means terminal on the controller. That's part of that legend that I was showing you earlier. It isn't repeated on this sheet, but it's repeated on all the others. Only because we actually ran out of room here. And then terminal V9 is going to be connected to terminal on controller, Bravo. So V9 is going to be connected to the B terminal on the controller. Then we show you Y4 is going to go to ASR/10 contact coil. And then D7 is going to go to greater than sign B, which is terminal on the controller, Bravo. And as you look at the sheet, you'll see we not only tell you what terminal on our unit is going to be connected where in the main controller, we're also telling you what area to find it in the print. So let's take a look at the area 2 on the print. Okay, this is what you would see. Area 2 says V8 is connected to RT1 terminal. And there V8 is connected to RT1 terminal. V9 was connected to terminal B. Well, it doesn't really show you well in this, but up here it says terminal B. Becomes really obvious. Here's our nudging unit, also wired in, and these are other terminals that we use. Now, the other thing you saw in that previous sheet was Y4. Let's go back. Y4 and delta 7. We're saying Y4 should be connected to ASR 10 coil. Let's take a look at where we drew in Y4. Here's Y4. Here's the ASR relay, and that's actually the coil number 10. And there's Yankee 4 connected there. And then D7 was going to be connected to B. Well, this is the common line, or the B terminal. So D7 is drawn in at B. So you can take these ponies, you can go back and forth. We tell you what area to find it in. Now, what we recommend is this. Before you begin the job, take these ponies, lay them out on a nice table. Also, lay out your prints and go through them terminal by terminal, from the pony to the print, and highlight everything. Once you've highlighted it, it's going to become really clear. Now notice here, and this is why we want you to highlight it. No place in the pony are we telling you to make this connection or make this break in the system. When we get to this circuit, we're going to tell you to go to area 2 and make these connections. But we're not going to, you won't know to open circuit. OPNCKT means open circuit. So what you're going to do is you're going to take all the wires off ASR 10 and put them to Zebra 2. Then you're going to put a new wire from Zebra 3 back to ASR 10 or Yankee 4. So Zebra 3 could be jumped to Yankee 4. You're going to see that in the prints later on. And then for this particular circuit, J4 is connected to RT1 terminal. Let's see if we can move on to something a little more. Okay, let's take a look at this one. And here we're telling you to go to area 2. And there's Z3, Z2, J8. These are the 3 terminals that we were just connecting in area 2. Okay, ASR 12 gets the Z2. Z3 is plus. Remember, plus means terminal on fire service unit. So Z3 is going to be jumped to Yankee 4 terminal on the fire service unit. And when you see a slash, ahead of the slash is the relay, the other side of the slash is the relay contact, in this case ASR contact 12. And we show that here too. Star slash star is relay slash contact. And then the greater than sign is terminal on control. This is the greater than sign. So basically that's the shorthand we use for the prints. And to make this really efficient, before you even get to the job, you really should sit down with these, go through the ponies, figure out what you're going to do. Now notice here again, there's no place where I'm actually showing you to break that circuit. But if you'll notice, we're asking you to open the circuit here. Now, there's a trick to opening circuits. A lot of guys don't get it. A lot of guys get confused with it. If you look at a terminal, let's say you look at ASR 12 contact. Can you guys see that? You can see that?
Yeah.
Okay. Now, if I had to open the ASR 12 circuit, what I would do is I would take all the wires that I find on that circuit, on that contact. Might be 1 wire, might be 2, might be 3. We don't know how the wiremen in the factory wired it. But I would take everything, all of them, off, and move them to this side of the open. And then put a new wire from Zebra 2 back to ASR. Let's step through here and see if we can see a better example. This is kind of obscure. Let me find a better example of that. Again, we're back to this again. And basically, this just takes you step by step, terminal by terminal, through the installation, so what area to find the circuit in. Here again, here's a couple more relays we paralleled here. X5, we probably wrote it up as DGX coil, DGY coil, or maybe DG3, DG/3, contact or DGZ/3 contact. That may be how we run it up. But I think the key to this, these paralleling circuits is a pretty simple operation. The key to this is breaking the circuits. There are only a few of them, but we have to break them clean. Here's another good example of a circuit break. We want to break the NT resistor cap network, RC network, out of the NT relay. NT, in Otis's case, is their door time. We want to eliminate door time. So what we do is we simply take the cap out. Hello, no door time. But the way we do it is by breaking the circuit with an FS contact. You'll find if you look at the prints, FS is all picked up when we first go on fire service, and they stay up through phase 1 and phase 2 operation. So what we're telling you is go ahead and hook A4 to the NT cap, NT resistor, and A8 should go to NT1 resistor. That's the way we're going to write it. But if you haven't looked at this, you won't know to open that circuit. You've got to look at the print. You've got to correlate what we're telling you to what you see on the print. And that's going to demonstrate to you that this is actually an open circuit. So how am I going to do it? Well, I can go to the band on the NT1 resistor, take the wire off, put it to A4, put a new wire from A8 back to NT1 band, or I can do the opposite. I can go to the NT resistor, which is mounted on top of the cap. I'm sure you've all seen the resistor with the little cap mounted on top. Capacitor with the little resistor mounted on top. You take the wire off the little resistor, you move it to A8, and put a new wire from A4 back to the resistor. You can go either way with it, but as long as you make sure that you isolate all the wires. Here's another good example. Down below here, we're breaking another circuit where we have Mary 6 terminal and Mary 5 terminal. So what we're doing is we're telling you, okay, Mary 5 should go to terminal coming up from the hatchway. I can't really read that. It might be A9. So what I would do is I would take all the controller wires off the A9 terminal. I would only leave the hatch wire on A9. And I would take all the wires I removed from the A9 terminal and put them to Mary 6 terminal. Now I know that I've isolated everything out that was on that terminal and I've broken the circuit clean. I didn't lose any wire, I didn't leave one connected. A lot of times I'll get a call, gee, this is happening, or the call comes to the landing and their door still is opening, even though I'm not pressing the door open button. The reason invariably is they haven't removed all the wires from one side of the circuit. They haven't broken the circuit correctly. They left a wire floating in there that's still connected. By using the method I described, by removing all the wires from here, by removing them all and moving them to the other side to add to Mary 6 terminal, you eliminate that possibility. You make sure that everything got moved, and you broke the circuit clean. Again, this is, more information about where to go. We're back to that. If you'll notice, these things are progressing. That was actually 2 different pictures with 2 different circuits added to the same page. This is designed for people who aren't quite that knowledgeable, so I can take them through one after another and show them how we build our fire service into the system one stage at a time. So if Charlie, say,
75.
is that 75? Or?
Yeah, looks like 75.
Yes, don't get old. My cheaters, I can't read that. Anyway, take all the controller wires off, C15, butt splice them together, run them to alpha 5, new wire from alpha 1 back to C15. By doing that, you've isolated the system and you know that you've moved everything out that has to go. Okay, this looks like, this is a parallel circuit. Simple parallel, X1 would go to E5, C5, and M7, Mary 7 would go to alpha 75. That's to jump out your stop switch.
Like somebody added a pit switch somehow,
Yeah.
kind of like the job we're about to do. There's no pit switch and turn off.
Now, we talked before about the reset panel. Well, let me go back and show you what that. If you find one of these sheets in your ponies, they're usually at the end of the pony sheets, 8.5 by 11 sheets. This is where you're going to hook up your reset panel. And again, it's pretty simple stuff. We're just telling you to take the 2-1 terminal connected to T8 on the main controller. 2-3 goes to terminal Bravo on the main controller. And then we go down the line. And this is what it would look like once installed. Now notice that we don't bring a separate wire back to the reset panel up here. What we do is we do it with arrows. In the old days, when I first started drawing these, and I was the original guy drawing these, I would try to draw a wire back from each terminal, and it just got so crazy. The arrows simply mean this is not connected to the terminal above, it just follows through to the reset panel. So don't get confused. I actually had a guy connect all these up one time. Yeah, I know. Why did you do that? Well, you show the arrow.
What it look like?
Makes sense. Couldn't argue with him. Okay, let's do it this way. He laughed when he was done. He said, wow, you think I would have caught that? He was really a funny guy. Anyway, this kind of shows you how the reset panel operates. In this case, when we go on fire emergency, the FM master picks up C1. When C1 picks up, we send a separate signal to every hall call in this case. It resets everything individually. Boom, boom, boom. We don't rely on any single contact to do the job. That was my experience many years ago, that when we did that, contacts didn't survive. Just didn't work. So we devised that whole panel. And that panel, remember, is designed to mount in or around the selector itself, not near the controller. It's designed to mount where the call relays are going to be located. And of course, this is the last of it. This kind of gives you now interconnections to all fire service units. Tells you how to connect everything. It's R9 to plus R9 to all fire service units. It tells you where to wire, how do you wire, what terminals to wire your key switch to, and what terminals to wire your lobby switch to. Again, you don't have to rely on the prints for that information. We document it here. Now, one of the things I haven't pointed out that maybe I'm remiss in not pointing out is this. If you look at these ponies, you'll see that we give you some information. We tell you what area to find each circuit in. We tell you what connections to make, but more importantly, every print, every pony sheet has cable. And then down along the side, right here, if I use, let's say I use yellow 4 to make this connection, I'll write in Y4. I'll write in Y3, Y7, orange 21, orange 23. So that when I'm done, if something isn't working and I have to go back and look at it, or down the line if a serviceman has to check a circuit, he'll have these pages to tell him what wire made that connection, what wire made that connection. Before I came here, yesterday I had a call from a guy. Something wasn't working. So I said, well, do you have a wire on, well, let's say, do you have a wire on Tango 8 terminal? Yeah. Well, it's supposed to go there, right? You see it on the print? Yeah. Where's it going? He went there. There was no connection to the terminal on the main controller. He said, well, I guess it doesn't go there. It's not connected there. Well, what wire number was it? So he went back in his ponies. He said, oh, yeah, okay, it's an orange 5. He pulled orange 5 and found out they had gone over 2 terminals. When they were wiring it, the guy was, I guess, had a brain fart and moved over 2 terminals and wired it there. So he took the wire off, put it where it had to be, and the system worked. But this is why it's kind of important to keep this. And again, this is filled in on the job, left on the job when you're done. Maybe copies should be brought back to here to store with your copy of the prints. We're going to supply you a job set of prints. When the job is completed, most companies will call us and say, okay, the job is done. Did you make any modifications? Anything that was right? Anything wrong that we had to change? No? Great. We send them out a final. The final usually goes to the job, and the original prints usually go to the office, or vice versa, depending on the company and how they want to do it. Most companies keep the finals in the office and leave the crappy printout on the job, which, as an old serviceman, I used to hate, but that's the way it is.
That's right. Someone's going to steal that print before you know it anyway.
There you go. And remember that, as I mentioned earlier, we have over 16,000 prints on file. So somebody steals your print. Hey, Jim, I need a new print for the Clark building. Okay. We run you off a set and send you out a new set. So we always keep a file. So nothing is ever actually lost. And maybe years later, you might acquire a job with our fire service unit on it. Of course, the company took the prints. Call us, send you out a new set for that job. That's another reason that we store everything that we store.